Mechanical properties of fluids. So now starting off with Pascal's law. Pascal's law. Well, according to this law, the pressure exerted by liquid column P is equal to the density of the liquid, the product of the density of the liquid into the height from the top and into gravity, which is G. So consider this as your liquid column. So then at height h from above, the pressure would be rho h in G. So this is Pascal's law. Now moving on to Bernoulli's principle. According to Bernoulli's principle, the pressure P plus rho into V square by 2, where V is the velocity, plus rho G H, that means the pressure exerted by the liquid column, is equal to constant. So this is another mechanical property of fluid. So Pascal's law and Bernoulli's principle. Moving on, the Stokes law. Well, according to Stokes' law, if a sphere of radius r is moving with the velocity v in some fluid of viscosity nu, this is nu, so nu, then the force acting on the sphere F is equal to minus of 6 pi nu a nu r v. Okay, now why is there a minus sign here? Because the force will be acting in the opposite direction of the motion. So this is Stokes' law. Now, terminal velocity. So well, if a body is allowed to freely fall down, considering air resistance, there will come a point where its velocity won't increase. So that velocity is called terminal velocity. So now the formula for terminal velocity Vt is equal to 2 by 9 r square into rho minus sigma g by nu. So this is the formula for terminal velocity. Moving on to surface tension. Now surface tension is a force per unit length, or the surface energy per unit area acting in the plane of interference. And then imagine this is a bubble, so there's going to be some force acting on the tension force. So it is tension force per unit area, in this case force per area, that is tension force, surface tension force. And now one more thing to remember: what is boiling point? The relation between boiling point and surface tension. Surface tension. Now well, the boiling point of a liquid is that temperature at which the surface tension becomes 0. So boiling point is equal to the temperature at which the surface tension becomes 0. So the surface tension is also 0 at the critical temperature. That's one more thing to remember. So the surface tension of a fluid is 0 during its boiling point, and also the surface tension is 0 at its critical temperature. Now, if a drop of water of radius r is broken into n number of droplets of radius small r, so or n identical drops, so then we can write that the work done W to break into n identical drops is equal to 4 pi r square s into n to the power 1 by 3 minus 1. So this is the formula for a big drop of radius r being broken down into n identical drops. So there's another formula. If this is here, S is tension, surface tension, and also another way of writing this is the work done is equal to, if here we have taken only one radius r, so if the small radius r is also given, then we can write that the work done is equal to the tension force multiplied by the change in area, so which can be written as surface tension into 4 pi r square minus 4 pi r capital square minus 4 pi r square, which this is if the small r is given. Now, if two capillary tubes each of radius r and are joined in parallel, that means basically water is flowing through both of them, or the fluid is flowing through both of them, are joined in parallel and the rate of flow is q. Now if you have to replace them by a single rod of or single capillary of radius capital R, then we can write that given that the rate of flow has to remain constant q, then we can write that capital R is equal to 2 to the power 1 by 4 R. So this is the formula for the relation between two capillaries in series, two capillaries in parallel, and the equivalent capillary radius. Now, in a liquid column, if in a capillary the increase in height, that means h, where here you can write this as theta, and the density is rho. So the h, that means the increase in height, is equal to 2s, where s is the surface tension, cos theta by r rho g. Now here r is the radius of the capillary. This is the formula for increase in height. Now moving on, coefficient of viscosity. Now the coefficient of viscosity, nu, can be written as the negative of force by area into d of v respect to dx. So nu is equal to minus f by a dv by dx. This is coefficient of viscosity. Now moving on to the last formula, velocity of efflux. So now if you consider a container with water or any liquid and you have a small opening, now the water coming out at this point at V, if you consider as V, Then we can write that V is equal to root over 2gh, where h is the height from the top of the container. So this is h, so velocity is equal to root 2gh. So this is the final formula of mechanical properties of fluid, and with this the revision is over. Thank you.